All right, so the value of the derivative means the same thing as find the slope of the tangent line. It's just a little bit of a different language. We're still doing the same thing. The derivative is the limit, in this case, as x approaches 2 of f of x minus f of 2 all over x minus 2. So putting that into the equation, we have the limit as x approaches 2 of 3 over x minus, and we're just plugging that into our function, 3 over 2 all over x minus 2. Now there's a few ways to simplify this complex fraction. In my opinion, the easiest way to do that is to take a look at whatever the just two denominators are. In this case, the denominator is x and 2. So a common denominator between those two is just 2x. So then I take this fraction and multiply the numerator times 2x, and then multiply the denominator by 2x. And again, I can do this because in essence I'm multiplying by 1. 2x over 2x is equal to 1. And then I get the limit as x approaches 2 is 3 over 2. So then I'm left with 3x times 2x minus 3 halves times 2x. And in the denominator, I'm just going to leave that as 2x times x minus 2 for right now. Now, the first part, the x's cancel, then the 2's cancel, and now I'm left with the limit as x approaches 2 of 6 minus 3x. And again, I'm just going to leave this portion factored. I still can't use direct substitution yet, but what I can do now is take the limit as x approaches 2 and factor the numerator. If I factor a 3 out of the numerator, I'm left with 2 minus x all over 2x times x minus 2. Now, this is an interesting case from college algebra or intermediate algebra. This is x minus 2 and 2 minus x. Those are exactly opposites of each other. So when they cancel, they are equal to a negative 1. Now what we are left with is just the limit as x approaches 2 of 3 over 2x. Now we can use direct substitution, and we see that the limit as x approaches 2 of 3 over 2 times 2 and remember this is a negative 1. I should have been a negative 3 over there. Excuse me. So that would equal a negative 3/4. So following this back up to the beginning, the value of the derivative, that is the slope of the tangent line, which is negative 3/4. If I want to go ahead and extend this question and ask you to find the equation of the tangent line, remember that anytime we ask for the equation of the tangent line, it's just y minus y1 is equal to mx minus x1. And in this case, we already had that the slope was equal to 3/4, and our point was given to us that x was equal to 2, and then we substituted that 2 in to find that value, which the y value, which is 3 halves. So plugging that in, I get y minus 3 halves is equal to negative 3/4 times x minus 2. Distribute the negative 3/4, and you are left with y minus 3/2 is equal to negative 3/4 x plus 6/4. 6/4 can be reduced to be 3/2. Add 3/2 to both sides. And the equation of the tangent line at that point is negative 3/4 x plus 6/2, or y is equal to, just separate this a little bit, y is equal to negative 3/4 x plus 3. And remember, this is the equation of the tangent line at x is equal to 2. All of the equations of the tangent line are unique. The function of the equations of a tangent line is what we will be doing next section.